Hello student, welcome back to lecture series on numerical methods. So in our today's video guys, we are going to start one of the fresh unit which is the interpolation, numerical difference and integration. Okay, it is the one of the point from the numerical methods. Okay, so here in our M3 syllabus it considered as a new unit. Okay, now see that this one is a very much easy unit guys. You just need to know some of the basic results. Okay, so without further ado, let's get dive into our today's lecture. First of all, we see what we needed basic here. Okay, so from next lecture onward we go for solving some of the example. Now see that this one is our sixth unit, interpolation, numerical difference and integration. Okay, it is also numerical method. Okay, so first point we are going to learn here the finite difference. Okay, what actually meaning of a finite difference. Okay, so you all are familiar with the function. Okay, so function, it can be written as y which is equal to f of x. Okay, I'm explaining here the finite difference. Okay, so we know that the function y which is equal to f of x. Okay, here the value of y corresponding to the different value of x. Okay, the value of this y which is corresponding to different value of x are obtained by substituting various value of x. Okay, yes, that means this y, it is dependent on the f of x, where the various value of x, whenever we substitute, we obtain the value of y. Okay, yes, so that means whenever we substitute the any different value of x, okay, we get the y over here. Okay, that means y varies. So let the consecutive value of x differing by h. Okay, so consider that x, it has some differ. Okay, and consider it as the h. Okay, like x naught plus h, x naught plus 2h, x naught plus nh. Okay, like we consider x as a x naught, then x naught plus h, then x naught plus 2h. Okay, x naught plus, take it to the nth value, x naught plus nh. Okay, x naught plus nh. So we consider x naught plus h as a x1 here, x naught plus 2h as a x2 here, and x naught plus nh as a xn here. X naught we cannot consider anything, so keep as x naught itself. Okay, as we have h, it is a difference, that's why we are taking x naught, x1, x2 as their okay, variable, and corresponding value of y of f of x. Okay, so we write corresponding value y which is equal to f of x. Okay, let me write corresponding value of y which is equal to f of x. Okay, corresponding value of y which is equal to f of x. So if we take y naught, then we write f of x naught. Okay, corresponding value means y naught which is equal to f of x naught. As x naught varies, y also varies. Okay, as x naught varies, y naught also varies. Okay, next, if you take x naught here, take y, replace y naught. Okay, so similarly, if x varies to x1, y naught also varies to y1. Okay, so y1 which is equal to f of x1. Okay, y1 which is equal to f of x1. So similarly, you can vary multiple value, y2 which is equal to f of x2, and so on, yn which is equal to f of xn. Okay, these are the multiple value that as x naught, x1, x2, x3, xn. If these are varying values over here, that means y naught, y1, y2, yn also varies here. Okay, the values of the independent variable x are called argument. Okay, the value of that independent variable, x called argument, need to remember. Okay, value of independent variable x called argument, and corresponding value of a dependent variable y. Okay, corresponding value, okay, dependent of a dependent variable y called as entries. Okay, we are going to use this terminology for our further part. Okay, now see that guys, might be first time it is quite confusing or difficult to understand over here, but once we continue some of the example, concept will be the crystal clear. Okay, yes, So these are the basic things that you need to know. Okay, finite difference means the difference here it is here, the difference h to h nh, these are the finite difference. Okay, so we consider it as the x0, x1, x2, xn. Okay, so on the corresponding value of y of f of x, that means if x varies, y varies. Okay, if f of x naught is there, y naught y goes to y naught. F of x1, y goes to y1. Okay, similarly you can vary this value. So all the corresponding value for x naught, x1, x2, xn are called the argument, and the y naught, y1, y2, all these values. Okay, so we consider it as the entries. Okay, yes. Now see that finite difference, it is having some subtopics. Okay, like a forward difference, like a backward difference. Okay, so these are also important. Let's go for a forward difference here. Okay, so forward difference, it comes from delta of f of x. Okay, delta is the some notations we use it in mathematics. Here it is a new point, forward difference or descending difference. It is a type of a finite difference. Okay, so it is a type for finite difference. We are going to learn what actually mean by the forward difference or descending difference. Okay, forward difference also called as descending difference. Okay, difference. So the first forward difference, okay, the first forward difference we all need to know, it denoted as first forward difference, it's written as delta of f of x. Okay, first forward difference, it is written as delta, or denoted as delta of f of x, and written as f of x plus h minus f of x, f of x plus h minus f of x. Okay, so this one is our first forward difference. Okay, first forward difference you need to know, guys. Okay, this one is important here. So using first forward difference, we are going to generate second forward difference, third forward difference, or nth forward difference. Okay, yes. So here this is a triangle shape, we call it as the delta. Okay, so if you don't know this triangle, we have denoted here now, so it called as delta. It is a delta, mathematical symbol, delta. Okay, so this one called as a forward difference, first forward difference or descending forward difference. Okay, so we are going to start from here. Okay, so what happen if the value for x varies, that means x0, x1, x2, x3. So if varies multiple times, we get the second forward difference, third forward difference, fourth, and so on. Okay, yes. So let's vary x to the x0. Okay, so we write delta of f of x0. Okay, delta of f of x0. So if you are replacing x as a x0, replace all the values here. F of x0 plus h, x can be replaced to the x0. Okay, minus f of x0. Okay, so this one is our first forward difference. I replace here x0 as a x as a x0. Okay, so I'm trying to find a second forward difference, third, and so on. Okay, yes. So we know that f of x, which is equal to y. This one is our function, we are working on it. Okay, so if f of x is y, then f of x0 also y naught. Okay, f of x0 also y naught, and f of x0 plus h also y naught. Okay, okay, f of x0 plus h, we are taking its some another value. Okay, so y naught is f of x0, then if the x0 plus h there, then consider some another variable. Okay, y1, take it to the y1. Okay, now delta of f of x0, so it is a difference. Okay, difference of f of x0. Okay, so keep that delta as it is, we are not going to change anything here. So difference of f of x0, we write it as the y naught. Delta of f of x0 is a y naught, so I'm replacing the f of x0 as a y naught. Okay, these are the corresponding value of f of x, which is equal to f of x0 plus h. Okay, x0 plus h, consider some another variable y1. Okay, minus f of x0 y naught. Okay, now see that delta of y naught can be written as y1 minus y naught. Okay, these are the value we are going to generate, guys. Okay, okay, so what happen if I'm going to replace x0 as a x0 plus h? Okay, x0 as a x0 plus h, so we are going to find the first forward difference, second forward difference, and multiple forward difference. Okay, yes. So replace x0 as a x0 plus h, so delta of f of x0 plus h. Okay, if x naught replaced by x naught plus h, this x naught also goes to the x naught plus h. That means f of x naught plus h, x naught replaced by x naught plus h, plus h, it is already there, minus f of x naught plus h. Okay, so what I have done here, just I replace x naught as a x naught plus h everywhere. Okay, so x naught h plus h means 2h. Okay, so you can write x naught plus 2h. Okay, so if f of x naught plus h is a y1, f of x naught plus 2h, consider it as a y2. Okay, f of x naught plus 2h is considered as y2. Okay, so delta of f of x naught plus h. Okay, so we write a delta of y1 which is equal to f of x naught plus 2h, take it to the y2, delta of y2. Okay, minus f of x naught plus h, y1. Okay, that means forward difference or delta of y1, we write y2 minus y1. Okay, forward difference of y0, we write y1 minus y0. Okay, these are the result we needed, guys, for further finding the forward differences. Okay, yes. So similarly, if you go for nth value, how can we find delta of yn minus 1? We write, if it is 1 there, then we take it 2. That means yn minus 1 means yn minus 1, that means you have to take to the last element. Okay, yn minus 1 plus 1, that means y1 plus 0 means y2, yn minus 1, that means yn minus 1 plus 1, that means we write it as the yn, and that yn minus 1. Okay, so this one is the nth result. Okay, nth result for finding the forward difference. Okay, forward difference. Okay, the difference of first forward difference called the second forward difference. Okay, so let me explain second forward difference, delta square of f of x and delta cube of f of x, these values. Okay, now see that I hope you all have understood how I have written these forward differences here. Okay, forward differences of f of x naught plus h, and yn minus 1, yn and y0. Okay, I hope you all have understood, not that difficult, it's one of the easy concept. Okay, yes. So let's go for finding the second forward difference, like a delta square of f of x. How can we find delta square of f of x? Okay, now see that we know that the delta of f of x as f of x plus h minus f of x. Okay, so we don't have delta square, so what I'm going to do basically here, I'm going to take one delta out of the bracket, another delta inside bracket, delta of f of x. Okay, delta into delta of f of x, that means delta into delta, it goes to delta square. Okay, and f of x as it is. So we know that delta of f of x can be written as f of x plus h minus f of x. Replace these values. Okay, so we write delta of f of x plus h minus f of x. Okay, delta of f of x plus h minus f of x. So apply delta separately here. Okay, so we write a delta square of f of x as delta of f of x plus h minus delta of f of x. So see that what I have done, I took that delta separately here and here also. Okay, so that means delta of f of x plus h minus delta of f of x. Okay, yes. So what we do, we apply a first forward difference, delta of f of x can be written as delta of f of x plus h minus f of x. Okay, and delta of f of x plus h can be written as f of x plus 2h minus f of x plus h. Okay, so I have to write this f of x plus h. Okay, we know that delta of f of x, what is the delta of f of x? Delta of f of x can be written as f of x plus h. Okay, minus f of x, f of x plus h minus f of x. Okay, this one is a delta of f of x. Okay, so after that delta of f of x I found here, I want the delta of f of x plus h. Okay, delta of f of x plus h, x replaced by x plus h, that means x replaced by x plus h and plus h, x plus 2h. Okay, minus f of x plus h. Okay, so x replaced by x plus h only, replace all these two values. Okay, this one and this one replace here. Okay, instead of these two values, so we write f of x plus 2h minus f of x plus h, f of x plus 2h minus f of x plus h. Okay, Okay, this one is a delta of f of x plus h minus delta of f of x. That means minus f of x plus h plus f of x minus f of x plus h plus f of x. What I have done, I multiplied minus to this one, okay, and directly written the values here. So this plus goes to minus and this minus goes to plus, okay, directly I written the step. So delta square of f of x can be written as delta square of f of x, it can be written as f of x plus 2h, keep as it is, we cannot change, minus f of x plus h minus f of x plus h minus 2 times f of x plus h plus f of x. This one is a delta square of f of x, okay. Now see that this one is our second forward difference. Similarly, you can go for the nth forward difference too, okay. Yes, see that this one is our no, this one consider it as the first forward difference, okay. As already we know that the delta of f of x as f of x plus h, we are finding the value, okay. So we are finding the value for delta square, delta cube, delta to the power 3, okay, and so on. So let's go for the next forward difference, delta square of f of x, okay. So we can write f of x plus 2h minus f of x plus h plus f of x, okay. This one is important. So if you want, you can replace the value of f of x as 1, okay. So delta square of y, which is equal to y1 minus 2 times y2 minus 2 times y1 plus y, okay, y2 minus 2 times y1 plus y. So you can replace the value as per the y x0 x1 y0 y1 as their corresponding value of y, which is equal to f of x. You see guys, I written here the equation, okay. So in the form of delta square of f of x, I written only as a delta square of f of x1, okay. So replace wherever you found the x in our last second forward difference, okay. So I replace x as the x1 here. So this x goes to x1, this x goes to x1, this x goes to x1, okay. Yes, so this is the delta square of f of x1, okay. So we know that f of x1 can be written as y1, x1 plus 2h can be written as y3, and f of x1 plus h can be written as y2, okay. And delta of f of x and f of x is y1, okay, f of x1 is y1, okay. So these are the corresponding values that I already explained, just need to replace, okay. So if you want, you can extend this value like a delta square of y2. So if y1 goes to y2, this y3 goes to y4, and this y2 goes to y3, and this y1 goes to y2. See that how easy to find out the second forward difference, okay. So we go for the third forward difference, okay. What is the third forward difference? Third forward difference, okay. That means the delta cube of f of x, delta cube of f of x is our third forward difference, okay. Delta cube of f of x, that means we can write delta into delta square of f of x, okay. So we know that the delta square of f of x as f of x plus 2h minus 2 times f of x plus h plus f of x, okay. So delta into delta f of x plus 2h minus f of minus 2 times f of x plus h minus 2 times f of x plus h, okay, that we found already before, plus f of x. This one is the delta square of f of x, okay. So I'll take delta separately to the every term, okay. So write down delta for every single term separately, okay. Delta of f of x plus h minus 2 times delta of f of x plus h, okay, and plus f of x. So just need to take the delta separately first. So see guys, I have applied delta separately to the every step, okay. So delta of f of x plus 2h, so we know that delta of f of x can be written as f of x plus h minus f of x, okay. F of x plus h minus f of x, let me write this one here, f of x plus h minus f of x. This one is a delta of f of x, okay. Delta of f of 2 times f of x plus h, okay. Delta of 2 times f of x plus h, two constant, take it outside, are not an issue, okay. So you can take this one outside, doesn't affect on our terms, okay. So means whenever x is there, then x plus h minus f of x, the x plus h is there, then x plus 2h minus f of x plus h, okay. and x plus 2h is there, x plus 3h minus f of x plus h. Okay, x plus 2h, that you need to understand the difference. So I'm going to write this one over here. This one is expanded here. Now minus, I'm going to expand this one. Okay, delta of f 2 times, to take it outside, so it is easier to find out the remaining value. Okay, to outside. Okay, so minus, this minus also take it outside. Okay, and f of x plus h, right? F of x plus 2h, f of x plus 2h minus f of x plus h. Okay, this one is a f of delta of f of x plus h. Okay, yes, so just need to understand, if x plus h there, then x plus 2h, and x is there, then x plus h. Okay, when x goes to x plus h. Okay, so this one expanded here. Now how to expand this one? Okay, this one here, see that how I'm expanding the terms. Okay, so delta of f of x plus 2h, take the f of x plus 2h first. Okay, now see that x plus 2, whenever we have x plus h, we start with x plus 2h, and whenever we have x plus 2h, take it one more here, so f of x plus 3h. Okay, x plus 2h there, then take it x plus 3h. Okay, minus, reduce one h from here. Okay, so we can write f of x plus 2h. So if you want, you can go for the general calculation, you will get the easily values. Okay, not that difficult. So this one is a delta cube of f of x. Okay, third forward difference, delta cube of f of x. Okay, similar term, take it together, and the remaining term cancel it if it possible. Okay, yes. So now see that f of x plus 3h is there anymore? No, we don't have f of x plus 3h. So we write only once, minus f of x plus 2h, minus 2 times f of x plus 2h. Okay, minus 3 times f of x plus 2h, minus 3 times f of x plus 2h. Okay, minus 3 times f of x plus 2h. So this one over, this one over, minus plus f of x plus h plus f of x plus h. Okay, okay, that means we have 1 times f of x plus, minus 2 times f of x plus 2 times f of x plus h plus f of x plus h, means plus 3 times f of x plus h. Okay, I hope you all have understood how I have written. Minus 2 here and minus 2 here, so minus minus gives us plus. So 2 times f of x plus h plus f of x plus h, 3 times f of x plus h. Okay, and minus f of x as it is. This one is a third forward difference. Okay, third forward difference. So if you want to replace x as a y1, f of x as a y1, okay, so you can write delta cube of y1. Okay, f of x I written as y1. Okay, f of x written as y1, then f of x plus 3h can be written as y4. Okay, now how I have written, we know that f of x naught which is equal to y naught. Okay, f of x naught is equal to y naught, f of x1 is a y1. Okay, f of x naught is y naught, f of x1 is y1. Okay, similarly that you have to take the values from here, here and here, everywhere. Okay, yes, f of x naught is again y naught, but we are taking as the f of x1. Okay, so if we are taking f of x1 here, this one is x1, this one is x1, this one is x1, x1 and x1. F of x1 is y1. Okay, f of x1 plus 3h is then y4. Okay, minus 3 as it is, x1 plus 2h, we write f of x1 plus 2h. So f of x1 plus 2h, we write minus 3 times y3. Okay, so 3h is a y4, 2h is a y3. Okay, yes, plus 3 times f of x plus h. Okay, and it's only h it is there, then we write y2, and minus f of x1 we write y1. Okay, this is the forward difference. Okay, this is a forward difference for third forward difference. Okay, so if in general if we take nth forward difference, then so let me define nth forward difference. Okay, I'm writing nth forward difference, nth forward difference. Okay, so I want the nth forward difference, that means delta to the power n of f of x. Okay, delta to the power n of f of x, delta to the power n of f of x. Now see that I'm going to vary the values. Okay, so if it is nth power, then we take one power reduce here, delta to the power n minus 1 f of x plus h minus delta to the power n minus 1 f of x. Okay, so if you are going to replace the value for n, Okay, if you are going to replace the value for n, you will get the all forward differences from this formula. Okay, from this formula. It is important, guys, not that difficult. Okay, these forward differences are okay. So I'm going to show these forward differences into the table format. Okay, everything I will take into the one single table and I will show you all here. Okay, yes, now see that need to understand this and the forward differences. Okay, so might be it is quite confusing at the beginning, but once we solve some of the example, okay, it will be the crystal clear for us. Okay, concept will be the crystal clear for us, not that difficult. Okay, I hope you all have understood the forward difference, how I have written all these formulas. Okay, finite difference, it is first forward difference, you can see it from here. Okay, I hope you all have understood. If you want, you can note this point down, okay, for your references. I hope you all have understood my today's lecture, guys. In my tomorrow's lecture, I'm gonna explain to you all one of the example based on the first forward difference. Okay, forward difference, then concept will be the clear for us. Okay, so that's it for today's lecture. Thank you everyone. Thank you for my today's lecture.